Today's work is going to continue to look at that standard form equation in which we have both the x and the y on the same side of the equation, and writing those equations and rearranging them into intercept form and doing a little bit of interpretation with them. And when we are looking at solving equations for y, when we're rearranging into intercept form, sometimes we end up dividing both sides by a number to get y by itself and then needing to simplify. So in the kind of warm-up, rewrite each quotient as a sum or a difference. That is really what's happening here. And remember, quotient means essentially divide. Like sum means to add, and difference means to subtract. So what we have here is a division problem, and we're going to rearrange it so it's either a sum or a difference. In other words, an addition or a subtraction problem. So when you divide a fraction, when you divide two terms by the same number, that means both of these are going to get divided by 2. So 4x is going to get divided by 2, and 4x divided by 2, 4 divided by 2 is 2, so that leaves us with 2x. And then that minus 10 divided by 2, 10 divided by 2 is 5, so it would be a minus 5. So notice now that quotient, that division problem, became a difference because now we see that those two terms are being subtracted. So in this case, we divide both terms by 2. Okay. Same thing in the next problem here. We're going to divide both terms by -2. All right, so we've got this piece right here and then this piece right here. So 1 divided by -2, you could write that as a decimal of -1/2. I'm just going to leave it as a fraction. So we can't really simplify that fraction, so we can just keep it as it is. So -1/2, and then -50x divided by -2, a negative divided by a negative is a positive, and so 50 divided by 2 would be 25, and then the x is there. All right, so notice that became a sum. The quotient became now a problem that is adding. So in this case, we divided both terms by -2. And then the last of this group, 5 times the quantity times the parentheses, x plus 10, all divided by 25. There's a couple different ways of actually simplifying this problem, and you get to the same answer. One way of doing it is maybe just to treat it as a distributive property first. And so that becomes 5 times x is 5x, and then 5 times 10 is 50. So 5x plus 50, still all divided by 25. And then we can kind of do what we did on the last problem. We can divide each part by 25. And so 5 divided by 25, okay, so that's going to be a fraction. That actually reduces to 1/5, so 1/5 x. And then 50 divided by 25 is 2. So 1/5 x plus 2 is what we get. Now we could also do it slightly differently right from the start and kind of treat this as its own division problem right here. So if we simplify the 5/25, that then becomes 1/5 times x plus 10, right, reducing that fraction. And then we could do the distributive property, multiply 1/5 times x, which is 1/5 x, and 1/5 times 10, 1/5 of 10 is 2. So notice that we get the same sum right here and here. We reorganize the steps. We rearrange the steps, doing the distributive property first versus doing the distributive property second. Okay, in this section, we're going to continue to think about slope as we are doing linear equations. Now, we did do a review of slope on our first day of class, so this is going to kind of overlap with that a little bit, but nevertheless, I think it's important to talk about slope as we continue to think about both writing our linear equations and graphing our linear equations. So recall that slope is the steepness and also the rate of change of a line. And what does slope tell us? Let's see, slope tells us that for every one x value, how much the y value is increasing or decreasing. Okay, so the slope really breaks it down into, for every one x, what's happening to the y. Is it going up or down by how much? The slope can be calculated, so let's say slope calculation. We think of it as a change in the y, how much the y is changing, divided by a change in the x. So it's a ratio between the change in the y and the change in the x. That's sometimes referred to as delta y over delta x. And we can subtract the y values of the 2 points to determine that change, and subtract the x values of the 2 points to determine that change. And sometimes we think of it as rise over run, which is the vertical change compared to the horizontal change. So there's a lot of different ways we think about slope. Ultimately, it's the change in y over change in x, which is the same thing as saying rise over run. So how is slope shown? So slope is shown on a graph. And let's see, maybe I'll change the color here. So if we have a line, we can think of the slope as the horizontal change versus the vertical change. So this is our run and this is our rise between the 2 points. So we're talking about rise over run, which is really a calculation of the steepness broken down into its rise and run, the vertical and horizontal components. We see that in equations like y equals mx plus b, right, where m is the slope, the number in front of the x there. We also see it in our slope-intercept form, our point slope form. Y minus y1 is equal to m times x minus x1, which we had talked about previously. And once again, that m, whatever the slope is of the line, that goes into that spot right there. So that's how we've kind of emphasized it so far and shown it so far.